Hello guys, in this lecture we are going to see the energy band of materials and properties of engineering materials. It has been shown by quantum theory that in crystalline material there are bands of allowed energy levels for atoms separated by bands of forbidden. Although for single atom the energy bands are discrete, it is found that the proximity of other atoms modifies the discrete energy levels of the individual atoms to the point where energy distribution take on the appearance of bands. This figure shows the energy band description of a metallic conductor. The partially filled band that is here refer to free or valence electrons possessing the highest energy. If small additional energy is added to the crystal, these electrons are raised to higher energy levels without prohibition. This is not true for those electrons with energy levels that place them in the filled band. Moreover, if energy is applied to this material in the form of an externally applied electric field, the conduction is found to occur. For this reason, the uppermost band, uppermost this uppermost band is called as conduction band. In a semiconductor material without impurities, this figure shows energy band description of semiconductors. The significant factor here is that the forbidden energy gap separating the filled valence band and empty conduction band is about 1 electron volt. This gap Eg is nothing but 1 electron volt. The electron volt is an unit in terms of which the energy of atomic particles are expressed. It is work done when an electron whose charge is small e coulombs is moved in the electric field through the potential difference of 1 volt against the force acting on the charge. Accordingly, as the temperature is increased, the electrons whose energy levels are raised beyond the gap level will be freed of their covalent bonds and become available for conduction. At the room temperature, approximately 1 out of 10 raised to 10 atoms has electrons so liberated. This figure shows the energy band description of an insulator. In this case, the energy gap is considerably larger than it is for semiconductors, with the result that at room temperature no covalent bonds are broken to provide free electrons in the conduction band. Even the application of extremely large electric field failed to rupture any appreciable number of covalent band. Thus, conductivity of such materials is practically nil. Properties of engineering materials. Properties of engineering materials in the practical application of all types of engineering materials depends upon the thorough knowledge of their particular properties under a wide range of conditions. Some of the most important properties of the materials are shown here, that are mechanical properties, thermal properties, electrical properties, magnetic properties, physical properties, chemical properties, optical properties, acoustic properties. Mechanical property includes the parameters strength, stiffness, elasticity, plasticity, ductility, toughness, hardness, brittleness, and malleability, etc. Thermal properties includes the parameters specific heat, thermal expansion, thermal conductivity, etc. Electrical properties includes conductivity, resistivity, dielectric permeability, dielectric strength. Magnetic properties includes the parameters permeability, coercive force, and physical property includes dimension, density, porosity, structure, etc. Chemical property includes corrosion, resistance, acidity, composition, oxidation, etc. Optical properties includes color, light transmission, light reflection, etc. And the last one, acoustic properties includes sound transmission and sound reflection, etc. And the last one, electrical engineering concept. The science of electrical engineering is based on just a few experimentally established fundamental laws. The principle and concepts that underline the operation and performance of many engineering devices are very often the same in spite of differences in appearance and arrangement. The electric circuit theory fundamentals came from the discoveries of Coulomb in 1785 by Ohm in 1827, Faraday in 1831, and Kirchhoff's in 1857. The complete concepts of electromagnetic devices and electromagnetic energy conversion can be analyzed by using Ampere's law in 1825 and Faraday's law of induction in 1831. The development of electronics came in 20th century. In circuit theory approach, the energy received by a device appearing between two terminals is expressed in terms of voltage and current. The three important circuit elements of electric circuit theory, which results from the fundamental investigations of Ohm, Faraday, and Coulomb, are respectively. The here figure shows of resistor. The first figure is of a resistor. Second is of magnet with the magnetic core and the coil, which indicates the inductance. And third one is of with the dielectric materials and the conducting plates, which indicates with the leads that is nothing but capacitance. These three parameters are the components play important role in electrical engineering. Each of these parameters can be viewed from the circuit point of view, energy point of view, and geometrical point of view. These three parameters depends on the properties of materials and their dimensions. The properties of materials associated with resistance, inductance, and capacitor are expressed in terms of conductivity or resistivity, permeability, and permittivity or dielectric constant respectively. The study of electrical engineering material is the study of these quantities only. Thank you very much. Thank you listening to me.